All right, so this one is chapter 2, section 4, and it's the inverse of a square matrix. So first off, I want to show and talk to you about what an identity matrix is. So an identity matrix is defined as the identity matrix and it's I sub n is the n by n square matrix with all zeros except for ones down the upper left to lower right diagonal. Examples. So if I said the identity matrix of a 2 by 2, it would look something like 1, 0, 0, 1. An identity matrix to a 3 by 3 looks like 1, 0, 0, 0, 1, 0, and 0, 0, 1. And then identity matrix to a 4 by 4, I mean, we can keep going. 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. You can see that it says from the upper left to the lower right. So upper left down to lower right, all of these are zeros. Upper left to the lower right, zeros. Upper left, lower right, all zeros. All right, that's what it means. And all the other entries are 0. Along with this, gives you something else too, and it says that if you take a matrix and multiply it by the identity, you get back the same matrix. So if you say matrix A, if you say matrix A times the identity, or you could also say the identity times the matrix, depending, still gives you back A. That's part of the definition here. Now, I also want to show you how you write. So writing a system of linear equations as a matrix equation. Now, I know that we've already talked about writing a system as a matrix, but now we're going to write it as a matrix equation. It's a little different. If we have the system negative 2x plus 4y equal to 2 and negative 3x plus 7y equal to 7, here's our system. We're going to look at it like ax equal to b. All right, where a is our coefficient, so negative 2, 4, negative 3, and 7. X is going to equal our variables, which is x comma y. And then b is what equals on the right side of the equation. So for our purposes here, it's going to be 2 and 7. So when we rewrite this, it looks like this. So ax equal to b is rewritten as negative 2, negative 3, 4, and 7. Our x matrix represents our variables, so x and y, and then equal to 2 and 7. All right, another definition here. So we're going to let A be a matrix, be an n by n matrix. So make it be square. And we're going to say the inverse of A, the inverse of A, and we denote the inverse of A, so it's denoted, looks like A to the negative 1 power, is the n by n matrix with the properties. If I take the identity, sorry, the inverse, and multiply it to the matrix, then I get back the identity. And likewise, depending on the size, of course, I can say that I take the matrix A and multiply it by the inverse, and I get back the identity as well. So how do you find the inverse of a matrix? Okay, so here's how we find the inverse of a 2 by 2 matrix, and we're going to focus on this. So the inverse of a 2 by 2 matrix. So to determine the inverse of a 2 by 2 matrix, let's let matrix A be A, B, C, D. And we're going to let D equal AD minus BC. And assume that D does not equal to 0. Then the inverse of A is given by the formula one over D, D, negative B, negative C, and A. This is how you will find the inverse. But you also have to know that D is this right here. So let's find that. All right, let's practice at that. I have enough room here. So example 1. Calculate the inverse. And we're going to say -2, -3, 4, and 7. So first off, we have to find what D is. Remember, our general form is this, is A, B, C, D. And in order to find D, D is A times D minus B times C. Okay, what it is it's the diagonals multiplied together, and then you subtract the two. So that's what we're going to take. We're going to take these diagonals, multiply them together. So our D equals A, write it out, AD, sorry, had a glitch, AD minus BC. Our A in this case is -2. Our D is 7. And then we're going to take and subtract it by -3 times 4, or 4 times -3. Minus 4 times -3. Which gives us -14 plus 12, which gives us -2. We know that it's not equal to 0, so we can continue to move on. If it was equal to 0, we would say that you cannot find the inverse. So we keep moving, and we say, all right, well, if we go based off our definition here, that it's 1 over D, and then what you do is you switch these two here. If this is the original, A is here, D is here. Now they become switched, right? So you switch these, So that's what we'll do for our original. And then B becomes negative and C becomes negative. That's what those are there. So what we're going to say is, to find the inverse now, we say negative 1/2, 1 over negative 2 is the same thing, times, and we're going to switch these, remember, we're switching these. So it's going to be 7 and negative 2. And then we rewrite these, but they're going to be opposites of each other. So instead of just 4, it's going to be negative 4. And even though it was negative 3, now it's going to be positive 3. And we do have to multiply that negative 1/2 in there. So our final that we have is negative 7 over 2. This gives you a positive 2. Gives you a negative 3 over 2. And this gives you a positive 1. This is our inverse. And we could say even this. We could say that negative 2, negative 3, 4, and 7. The inverse of that is negative 7/2, 2, negative 3/2, 1. All right, now the reason why I showed you how to do a matrix equation is because you're going to have to be able to solve a matrix equation. So solving a matrix equation. If the matrix A has an inverse, then the solution of the matrix equation is A times X equal to B, is given by X equals the inverse of A times B. So if we can write it as A times the matrix A times the matrix X equals the matrix B, if we're just trying to find X, then we can just say that if we have the inverse, we can multiply that by B, and then that's all we have to do. So example 2. Use a matrix equation to solve the system. Negative 2x plus 4y equal to 2. Negative 3x plus 7y equal to 7. This should look familiar because it's really the problem that we did earlier. I just didn't write it like that. Okay, so example 1, we found the inverse of negative 2, negative 3, 4, and 7. We're going to call this matrix A. Matrix X will be our variables, which is X and Y. And then our matrix B is what it equals, which in our case is 2 and 7. Well, based off our definition from a little while ago, it says that if I'm trying to find X, if I know its inverse, I can multiply it by the matrix B, and then I can go from there, and I can find my answer. Well, like I said, this matrix A we just used in the last example, so we already know its inverse. And the inverse that we came up with was the inverse of A was negative 7 over 2, negative 3 over 2, and we have 2 and 1. So based off our definition, that we know that the inverse of A times B is X, then we know that the inverse, -7/2, -3/2, 2 and 1, if we multiply it by the B matrix, which is 2 and 7, then we should be able to find out what x is. So as a review on multiplication, it's the row times the column. So it's -7/2 times 2, which is just -7. Let me space this out a little bit. And then it's 2 times 7, which is 14. Oops, sorry, I wrote in the wrong spot. Plus 14. Then we come down to here and we say row times column. So -3/2 times 2, which is -3. Plus, and then we have 1 times 7, which is 7. So -7 plus 14 is +7. And then -3 plus 7 is +4. What does that tell us? That tells us that x is 7 and y is 4. Right? Because we said that our matrix X, this was X, this was Y. So this is X, this is Y.